My name is Michelle Felance. I was the project manager and I did the SWIP plan.
My name is Ryan Siffel and I performed the traffic analysis.
My name is TJ Grace and I did the foundation settlement.
Hi, my name is Connor Shelto and I worked on the foundation settlement calculations.
Our project is the Luhrs Marriott Hotel by Performance Design. To give you a brief overview of the project, the Luhrs Marriott Hotel is located in Phoenix, Arizona. It has been estimated to cost around $50 million and is 240,000 square feet. It is a dual-flagged hotel consisting of 20 floors. The bottom half will be a courtyard Marriott and the top half will be a residence inn. Performance Design focused on these following items to develop our submittal: a traffic study to see how the hotel will affect traffic before, during, and after construction, the foundation settlement calculations to determine how much the building will settle over a course of 50 years, a SWIP to prevent stormwater contamination during construction, and a formwork estimate to verify pricing.
So for my part of the project, I performed the traffic study. The purpose of our traffic study was to determine if the existing infrastructure in the downtown Phoenix area could properly support the amount of traffic that construction would bring and post-building occupancy would bring. So to generate our data for this, we researched at the State of Nevada Traffic Control website to find some existing traffic volumes that existed in the 4 surrounding intersections. Of those 4 intersections we were able to find data for, we decided that there were only 3 that really provided a critical access points for the downtown area and the hotel itself. Those intersections you can see on the diagram provided. So on the left side is the current, what's existing, and on the right side you see what we're going to experience once construction begins. We're going to need to shut down the westmost lane on South Central Avenue as well as the northern lane on Madison Street. So our analysis will be focusing then on intersection 2, as that is the one most critically impacted by the shutdowns. So as we move over to some of the results we were able to obtain, you can see that our intersections 1 and 3 were actually able to maintain the existing level of service from start to finish, which is very exciting news. That means that no traffic control volumes will have to be put in place there. Our only impact is going to be at intersection 2. As you look at the during construction conditions table, you'll see that we are able to maintain the level of service B threshold as we are below the 20-second vehicle delay, which is a big positive. We're excited about that. We won't need to implement any flaggers or any type of traffic control. However, once we reach post-completion and building occupancy, you can see that Madison Street at intersection 2 will bump up to a level of service C as its total delay extends to 20 seconds, which again is only about 2 seconds longer than existing. It's more the letter that's a deterrent going from B to C, but we're still very happy with this. A 2-second delay is nothing for the amount of people that will be trafficking this building and the downtown area in whole. So we're very happy with these results.
So the purpose of the foundation settlement is to find the long-term settlement of the MAT foundation over the course of the next 50 years of construction. As in this problem, the MAT foundation is a 52-inch thick slab underneath the entire building. So it's important to understand how far this foundation is going to settle into the ground over time because it's going to be taking some pretty heavy loads. So our approach for this problem was first use soil data found from sources in the Phoenix, Arizona area in order to really kind of realize what kind of soil we were dealing with underneath this building. Second, find the live and dead loads from the drawings. So we digged into those and took some takeoffs and were able to come up with a number for both the live and dead loads, which we then combined. And as well, we used information from our Civ 465 geotechnical class in the shallow foundation section. So we used formulas in that section of the reader in order to calculate the long-term settlement. So from our research for soil data in the Arizona area, as well as sources found in the Civ 465 reader, we were able to come up with a realistic soil profile for underneath the MAT foundation. As you can see, the first layer is 2 meters deep and it's high plasticity clay, and underneath that is 10 meters of low plasticity clay, and under that is bedrock. So with that being said, the soil profile in place, we're able to use formulas and find the settlement. So in conclusion, we were able to use the formulas found in the Civ V465 reader, and we came up with a settlement of 23.2 centimeters over the course of 50 years, which we feel is very reasonable, and we're comfortable with that number.
The purpose of this stormwater pollution prevention plan was to design a plan to prevent stormwater contamination during the construction of the hotel by implementing certain BMPs. My approach to this section was to determine the surrounding discharge sites and impaired waters, and as well as determine the receiving water risk in order to figure out what BMPs were necessary. By using SMARTS, which is the Stormwater Multiple Application and Report Tracking System, and the Rainfall Erosivity Factor Calculator, I was able to determine the R, K, and LS factors in order to determine the sediment risk. The project turned out to have low sediment risk. With that information, I was able to design a plan that included the following BMPs: curb inlet protection using filter fence fabric drops, provide a washdown area to keep dust controlled, road sweeping and track out cleaning, sandbag barriers, and a water truck spray downs for dust control. By implementing these BMPs, we can be sure that the site will not contaminate the area around it.
The purpose of performing a concrete formwork estimate was to verify the pricing of the building by comparing it to a concrete estimate performed by Hensel Phelps. My approach was to use on-screen takeoff software to perform a quantity takeoff of the concrete and then use a labor rate sheet to calculate the cost. Here is a screenshot of the program I used to perform the takeoffs. After gathering all of my data, I concluded that the total amount of formwork that is needed on the project is 381,962 square feet, which costs $2,305,109. The tables below show a breakdown of how much each level costs.
We competed in the ASC Reno competition in February, and this is where our project comes from. Essentially, the competition focuses on construction management, and we were asked to do various things like scheduling, estimating, and construction planning. At the competition, we ended up taking home third place in the commercial division out of a very competitive field of 16 teams. Our senior design project is based off of the project that was given to us at this competition. We added on various civil components for our project for this semester to create a comprehensive submittal. Thank you for watching.